Have you ever heard of the long jump? Well, it's exactly what it sounds like.
We can think of the long jump as a projectile motion problem. Let's break it down to its horizontal and vertical components. The horizontal velocity is a speed that was built up as the runner sprinted down the runway, and the vertical velocity is the speed at which the runner jumps straight up at the point of takeoff. The actual speed of the runner is a resultant of the two vectors. For a projectile problem, the maximum range for a given horizontal velocity is achieved at an angle of 45 degrees. For example, if a runner was running at 10 meters per second, then their actual velocity at takeoff would be 14 meters per second. This is much greater than compared to a launch angle of 30 degrees or 20 degrees.
Let's take a look at Mike Powell, the world record holder for the long jump, who set the current record for a man of 8.95 meters, around the length of 2 cars. His initial running speed was measured to be 11 meters per second and a takeoff angle of 33 degrees. Yes, you heard right, 33 degrees. While most people might think that the optimal angle of takeoff is 45 degrees, it is actually not true. Gravity acts on vertical velocity, pulling the jumper downwards. It is also easier to gain large horizontal velocity than vertical velocity.
Imagine Usain Bolt, the world's fastest man, attempting the long jump. At one of the championships he attended, he was able to attain a speed of 12 meters per second. With the ideal conditions and everything accounted for, Usain Bolt could achieve a long jump distance of 10.50 meters with a takeoff angle of 33.24 degrees. His takeoff speed, V1, would be 9.98 meters per second.
What do you think? Can you beat the world record?